Thank you to our sponsors, Rockwell Automation, Advantis, and Damn Sci-Fly. To walk you through the events that we've prepared for the next few hours. So from 1 o'clock right now to 5 o'clock, we have a series of tech talks from some of our ride judges from the event. And we also have a series of features of prominent ride modelers outside of the competition who have been able to create some incredible work. So coming up at 1:15, we have a tech talk from Linda Freeman of Rockwell Automation, giving an introduction to safety in the amusement industry and how all of that works. Then we'll have a feature at 1:30 of Dan Fritchie of his entirely 3D printed launched roller coaster. At 1:45, we have a tech talk from Advantis CEO Philip Gearing on the risk assessment process in the ride engineering industry. At 2:30, we have a feature with Jared Holliday from University of Cincinnati for his 3D printed roller coaster model with a fully functional ride control system akin to what you would see on a real full-size ride. At 2:45, we have a tech talk on ride control systems from Gabe Russ of Irvine Andre Engineering. At 3:15, we have a feature with Matt Schmatzer, who is Print My Ride Detroit, who has created some incredible functional 3D printed and scale models of roller coasters. And at 4:15, we have a tech talk with Linda Freeman of Rockwell Automation talking about ASTM F24 and what students can do to get involved in the ride engineering industry. So we hope you enjoy all of these, and we'll be showing the ride model streams intercut throughout, as well as some additional material from our sponsors. Thank you all for joining us, and enjoy the program.
Calling makers. Playmakers and makers. Rainmakers. Noise makers and makers. News makers. Who make experiences count. Those who make machines faster and smarter. Call on those who want to make an impact by experimenting, pushing, questioning, persisting. Those who make customers delight and collaborate across time zones and industries. Those who innovate data, making a difference through lens zero. Those who desire to make the impossible possible. Join us. Makers Wanted.
My name's Linda Freeman. I work with Rockwell Automation. We're an industrial automation company, and we do control systems for amusement rides and attractions. I'm here today, got a couple of notes written down, some things I want to talk to you about. So every industry, no matter what industry you work in, needs safety. Safety is very important. But when we think about the amusement industry, safety is core to everything that we do in the industry. We need to keep our employees safe, and most importantly, we need to keep our guests safe. So how do businesses ensure safety? One of the ways they do that is they abide by standards. Standards are best practices that are written by volunteers. The volunteers include experienced professionals, interested parties, and also students. So what do? They go to meetings and they sit down and they talk about, these are the types of things we've seen happen in the workplace. These are incidents that have happened. So let's write down some best practices so that we can teach others what to do so that they don't have the same safety incidents. So the organizations that do that are called Standards Development Organizations, SDOs. And there's quite a few of those that exist around the world. EN is out of Europe. There's ISO, IEC, and one of the very common ones in the amusement industry is called ASTM. So ASTM International is in over 110 countries around the world. They develop over 500 different standards, and they have different committees. And the Committee for Amusement Rides and Devices is called F24. So ASTM F24. That's what you want to go Google. And you will find the Amusement Rides and Devices Committee. And then within that committee, they publish a lot of different standards. The standards apply to fixed attractions, mobile attractions, zip lines, water rides, all sorts of different types of attractions. But the standards are mainly grouped into 3 different categories. So you've got design standards, maintenance standards, and operations standards. So we think about the entire life cycle of an attraction and what are the different types of safety things that we need to be thinking about when we're designing the attraction, when we're maintaining it, and when we're operating it. So if you want to get involved in those organizations, like I said, it can be experienced professionals that have worked in the industry for many years. It can just be interested parties. We have some people that come to the meetings that just love the industry and they want to contribute. We also have lots of students. We need diversity of thought when we're creating standards, because not just one person in that one viewpoint is going to write the best standard. When you look at it from all different perspectives, all different job functions, different experiences, that's when we can write the best practices, because we want someone to be able to pick up this standard who knows nothing about it, read the standard, understand what the best practice is, and then ensure safety in their operations and in their designs. So I encourage you, if you're a professional listening to this and you want to learn more, go check out in your industry who are the standard development organizations that write safety standards for the field that you work in. If you're a student and you want to learn more about the amusement industry, go look up ASTM F24, become a student member. A lot of universities actually have a subscription where you can get all of the standards and you can download them and read them. You will learn so much. That's one of the goals of this competition, is that we want people to have hands-on experience with those standards. So if you're competing in the competition this year, congrats. You've got some great experience to now feed your future. Or if you didn't compete this year, then definitely, please come join us next year, because you're getting some real good hands-on experience. So standards development organizations are very important. Within the amusement industry, there's kind of 3 major organizations. There's ASTM F24, there's an ISO standard, and then there's an EN standard that's in Europe.
Advantis, a company that provides a software to do risk assessment for amusement rides and devices. My background is controls. I've been in the industry for 25 years, worked for several ride manufacturers, worked for Rockwell Automation for a while, and now have my own company. Besides Advantis, Gearing Engineering, doing control system design work and risk assessment. I'm also a member of the IAAPA Safety Subcommittee here in Europe, and I'm an ASTM member, and I'm the co-chair of the new Foreign Risk Assessment Task Group, responsible for the new risk assessment standard coming out, let's say, within the next 12 months. So.
All right, so what is a risk assessment?
A risk assessment is basically a formal approach to look at any kind of machinery. It doesn't have to be a ride, because risk assessments are conducted in numerous industries, in order to get an understanding of the risks associated with that machine. So a risk assessment always starts with a hazard identification. That's one of the key elements. So first of all, you want to analyze what are the potential hazards for a person interacting with a machine, or in our case, with an amusement ride. And these persons can be obviously the guests, operators, and maintenance personnel. So in a risk assessment, you want to look at all three people involved, and you want to identify where can these people get potentially injured. Okay. And then maybe I go on what the other key elements are. That once you've identified these hazards, then you do an initial assessment of these so-called hazardous events that could occur. So you have a person that is executing some kind of task on this machine or on the ride. You look at the hazardous event that could occur. So now you look at what is the severity of the outcome, how bad is it, how bad could that person be injured, and what's the probability of occurrence that the event is happening and that that person gets harmed. That's your initial assessment. Then if you find out this is an intolerable risk, you should look into risk reduction measures. And you can have multiple risk reduction measures, and after each measure, you do a reassessment. You look at how bad is it now, or what's the probability of occurrence now. And so you want to get down to a tolerable residual risk. So the process is always the same. For any given hazardous event, the process is always the same. We call that a case. In Advantis, in our software, we call that a single case.
So in the amusement ride industry, who is doing risk assessments?
Good question. First of all, I would say over here in Europe, with our standard that we have in place here in Europe, the ride manufacturer has always been tasked to do a risk assessment. For the past 15 years, ride manufacturers would do a risk assessment on their equipment. Basically on the ride that they sell to a park, they would do a risk assessment. Now we've changed the standard in a way that the park also needs to do a risk assessment. So now we distinguish between a DRA, a design risk assessment, and an OURA, operation and use risk assessment. So the one that OURA that the park needs to do focuses much more on the operator and on maintenance, because these are the folks that a ride manufacturer would not necessarily focus on. So we're getting more and more comprehensive to make sure we cover all the risks associated with a ride.
All right, so why is risk assessment important?
Why is it important? First of all, we've been talking about risk assessments lately more and more, but even before, you got to think, people have always done a risk assessment. They've just done it in their head. They've never written it down, and then they did a design based on what they thought. They're like, well, you know, this is kind of critical. Let's put 2 sensors here, or let's beef this up. Let's put a bigger safety factor to this piece, because I think it's kind of important that this, whatever, wheel doesn't snap off, or that this this coach coupling doesn't snap. I think it's kind of not good if a coach coupling breaks. So let's beef it up. So people have always done it. It's just never been written down formally, and that's basically what we're doing now. We're setting it up on the standard side. We're setting the process up, what needs to be documented and how it needs to be documented, so that we can actually compare these risk assessments and have a clear process and a clear form. So in order to do the design correct, you have to do a risk assessment. Whether you write it down or not, you're doing it anyway. So it is very important that you do your risk assessment beforehand. Only on a conceptual design, you should already start with your risk assessment. You should not be doing a detailed design before you have the first round of your risk assessment done. This is absolutely crucial, or you don't have a target to design towards in your design. Okay.
All right. How have students in this competition been able to be introduced to risk assessment?
Well, because we introduced them back in October, thanks to our connection, we introduced them through a webinar to Advantis, the software. I gave a 1-hour introduction, and we've given all these teams an account, a free trial account. That's part of our sponsorship here, that these students were able to use Advantis with all the features, no limitations at all, over the last 6 months. And we've given them some guidance through the webinar, through collateral, such as manuals, and then also a template project. They had a template project in their folder, so they had some ways to look at it, and that's how we introduced them to this. And that just started my review as a judge, and I have to say, they look pretty promising. They've definitely put some effort in here, so looking promising.
All right. So what can engineering students out there do to learn more about risk assessment, to get more experience with risk assessment?
First of all, there is courses that we give. We have an academy. Advantis Academy provides training courses. Whoever is interested can approach us at Advantis, and we'll provide dedicated courses for individuals besides the collateral that we already have on our website. Then, of course, there's the standards. You can read through a standard, but that's pretty darn dry and boring. So I recommend get in touch with me. It's way more entertaining. Plus, I can spice everything up with some real examples out of the industry. You know, that the standards are cut and dry, but when you bring up some examples, and we can do an online course. In the past, I've done, front training with many organizations on risk assessment, but we can do individual sessions with whoever is interested. So just go to advantis.tech, send us an email and get in touch with me, and I'm happy to help any students that want to get involved in risk assessment, because we need more folks being familiar with how to do a good risk assessment.
Right. Well, thank you so much for, not only sitting down, but sponsoring us throughout the year and giving all of this opportunity to our students.
Sure. Very welcome. It was a pleasure. I'm really happy to get engaged with young students, eager to learn and to do the right things. So thumbs up for all the organizational work you're doing, Charlie. Really, I'm impressed of what you're setting up here, and good luck in your competition. Take care.
Montreal. We're doing what we're calling a downtime highlights. As a part of this competition and as a part of the engineering process in general, is the things that we build sometimes break. And so we actually contacted a team who had a bit of breakage earlier this stream when the ride was operating. They were able to fix it, and now we're having them in a Zoom call. So we're calling in the Rochester Institute of Technology so they can talk about what happened. RIT, can you hear me?
Right. Let me see.
Oh, I can hear you.
Yeah, I can hear you.
Hey, okay, perfect.
Nice, cool.
Well, thank
Hello.
you guys. Thank you guys for making even more time for this competition, for this type of shindig. So, could you just walk us through what happened with your ride?
Yeah, do you want to do it?
Okay, so our ride uses a string to pull the carriage up and down, wrapped around a pulley, and one of the strings stretched more than the other string, and it was causing unequal forces being pulled up on either side of the carriage. That was causing it to bind on one side, and we were experiencing more friction.
Okay.
So our motor wasn't programmed to deal with that friction, and so we took it apart and rebalanced the wires, and it worked fine after that.
Nice. And so, through that uneven tension force in your ride, did that result in a safe stoppage? Were the riders harmed at all?
No.
No. Perfect. And did you anticipate anything like this when it came to that?
Yeah, we were expecting, so since we are using a rope, we were expecting it to kind of stretch out as the day goes on, and we actually have extra rope on hand, but luckily this scenario, we just had to retie the rope so that it was a little bit tighter on the side that had become more loose, and that evened out everything.
Yeah, so you expected something similar to this, and so that was,
Yeah.
so you had it written down, something like that.
Yep.
That's good to hear. Let's see. Were you able to get your ride operating again?
Yeah, it
Yeah.
took about 20 to 30 minutes, but we were able to get it. Yeah. And we had a couple of minor stoppages as well. I don't know if you want to talk about.
Took 26 minutes.
Yeah, 26 minutes for
26
that was our main stop. But we have a removable section at the top, and one of our panels is removable as well, so it's easy to access the counterweight in the center for us to fix. And then we also applied some lubricant to help it slide smoother at the bottom, because that's where we kind of experience more friction as well. So
Awesome. That's good to hear. I believe that's all that we really have for this interview right now. Thank you guys for coming out. I know it's a busy day for you guys. And then,
yeah, thank you for having us.
soon we'll be going back into videos. So thank you guys.
Thank you.
So I'm Jared Holliday, a computer engineering student at the University of Cincinnati, and right behind me, this is the model roller coaster that I've been working on with our College of Engineering Applied Science and Rockwell Automation. It's been a super fun project to put together, and I'm super excited to talk about it today.
All right, what's special about this project?
So the coolest part about this model roller coaster is definitely the control system over here. So the control system is definitely a super interesting portion of this project because it's all PLC controlled just like the real ride would be. So we've got, a safety PLC that is ensuring that the trains are in the right spot at all times. We've got sensors that are detecting where the trains are on the track, and then, a bunch of motors on there that are all moving the trains to their proper location. And it's basically set up to have a block system just like a real roller coaster. So it's keeping the trains separated, making sure that none of the trains are entering those block zones when they're not supposed to be. And then also the system is monitoring the whole operation of the ride, and will actually fault just like the real thing. Those times when you see the roller coaster stuck up on the lift hill, and you got the maintenance guy to come out, it will emulate exactly how that works. And the really cool thing about this is that because it's a model, we can actually, trigger those faults and show people like, hey, here is how a fault would occur on a real ride, and here is what is actually happening. Because you always see those news articles out there that are like, big fault on the ride, people are stranded in midair for 6 hours, our amusement ride's safe. And, we're trying to show people that, yes, amusement rides are definitely safe, and that is the safety control system keeping riders safe by stopping it when it gets kind of confused about something. And the ride system can get confused about any number of things, right? Like a faulty sensor on the track. I mean, you could literally, have something fly in front of a sensor at the wrong time. And the ride system, for all it knows, right, is that there's a train there. And we don't want to send a train full of passengers into a zone that we're not 100% sure about. So we just stop everything and allow, a human person to come out and check and make sure everything's all right, and then turn the ride back on. So yeah, that's what this whole system is all about. It's very cool.
What aspects of a ride control system make it safe, even when unexpected things might happen?
So it's really all, so we're talking about things that keep the ride control system safe when something unexpected happens. And the whole idea is that you have redundancy in the system. So that means that we have, if some part fails, we have something else to come in and take up the slack for that failed part. And make sure that we can stop safely in every condition with the parts that we have. So one of the things that the electrical system has is, behind me you can see that the safety PLC has actually 2 modules in it. So that means that we have a safety PLC and then a safety partner. And the idea behind that is that those 2 are checking each other to make sure that that is, you know, what we're about to do is really what we know is true, because both of those PLCs are checking each other to verify. Another point of redundancy on the ride system that I have is the brakes. So on my brakes, I allow the trains, only 3 of the brakes have to be active to actually stop the train within the block. But I have 5 brakes total there, so even if one brake fails, we can still stop the train in that block zone, no problem. And furthermore, on the brakes specifically, the brakes are actually monitored. So there are little sensors on the brakes that are detecting which position the brakes are open or closed. And so a thing that we check before the train goes over the lift hill is to verify that all those brakes are in the closed position 100%. And if one of those brakes is open, then we won't send the train over the top of the hill, and we'll cause a fault and say, hey, the brakes aren't closed right now. We can't, you know, send the train into the next block zone because it won't be safe to stop it. So yeah, that's just a little bit about redundancy in the ride system, and also verifying that everything is operating within its design parameters before we make any decisions that will send the train forward into the next zone. So yeah.
All right, what inspired you to take on this project?
So it has been, the thing that inspired me to really take on this project has been just my entire history with roller coasters. Like, ever since I can remember, I have just been in love with the amusement park, and it's just amazing. But the thing that really got me into all of this was being at Kings Island constantly and standing in line for rides like Diamondback and, you know, the Beast. And one of the things that I thought was really cool about the ride was that after the train went over the top of the hill, the lift slowed down. And I was like, and I built some K'NEX roller coasters at home, right? And I was like, man, these are just not realistic enough. The lift has to slow down after the train goes over the top of the hill. So I bought myself an NXT, like a Lego Mindstorms, and that was my first automated model roller coaster. Was with like 2 motors and a Lego Mindstorms NXT, and all it did was, when the train entered the lift, it would, you know, speed the lift hill up, move it over, and then it would slow down. And then the coasters, I was always trying to get more and more realistic, because my favorite part of building the models at that point was definitely the electrical control system, and I just wanted to make the control system even more and more realistic. So I added a control panel one time, and then I was like, no, it's not realistic enough. We need a PLC in here. So I went to eBay and I bought a PLC, and then I started learning how to program PLCs from that, and it just ballooned out of control. I was like, I need a transfer track on the next one, and there was a transfer track in the next one. So, you know, and then this one, I was actually in class one day in my Electronics 2 class, or I think it was actually Electronics 1. I was in my Electronics 1 class, and my lab tech, his name is Jason Heil, he goes, he brought in a cart with a bunch of Alan Bradley stuff, and I was like, oh, what's all the Alan Bradley equipment for? And he's like, oh, we're swapping out our Slick 500 PLCs for new Compact Logix PLCs for our PLC class. And I was like, oh, that's cool. Well, if you don't have anything to do with those Slick 500 PLCs, you just call me, right? And so from that, he was like, oh, what are you going to use it for? And then, you know, from that, we kind of took on to this idea of building a model for the university. Now, the whole idea behind building the model for the university is that over time, as I kept developing my model roller coasters, I started enjoying kind of taking them to events, you know, like taking them to STEM education events. And something that I found really interesting was that students really love the idea of, students relate easily to roller coasters, right? And when you stick something like a complicated industrial control system onto something that's relatable, they really connect with it very easily. And more so because, from the start, everybody's been like, hey, model roller coasters are great for showing off physics, right? They're great physics demonstrations. I found that model roller coasters are also really great demonstrations of electrical control systems, because nobody really wants to sit there and watch a conveyor belt move a little object by. That's not going to resonate with like every kid. But you put a giant roller coaster in front of them and they go, whoa, I pushed that green button and it made it go, right? And they start kind of putting it together. So the university was looking for a new STEM education item that they could use, and this is what we came up with, and that's how we got Rockwell Automation on board as well. We said, hey, we want to build this really cool STEM education model, and so now going forward, the University of Cincinnati and Rockwell Automation are kind of going to share this as like a STEM education tool that they'll use ongoing after I'm finished with the project here in April. So yeah.
All right, so you talked about starting out with K'NEX roller coasters. What were the early versions of this kind of STEM tool with a ride control system, and how did that evolve into this newest version?
Yeah, so the question is, how did my K'NEX roller coasters really evolve into this thing right here? So like I said, I started out with just the NXT models, and they kind of took over my parents' basement. So I had really nice parents growing up. They let me take over their downstairs basement to build these things, and they were not portable at all. But over time, I was like, I kind of want to show people what this is, right? Because it's kind of cool, and I think people would like it. And I was a part of an organization called the Inner Alliance at my high school, and they were like, hey, Jared, we know you build these really cool model roller coasters. You could probably do a neat presentation about these at an event that they hold here in Cincinnati called Tech Olympics. And I was like, okay, cool. Well, I can put something together. And so I put together a smaller version of the model that I had like that was strewn across my entire basement. And this one was very basic. It just had like 3 blocks. It had a lift hill, a station, and then a brake run. And it was literally controlled by like 2 solenoid valves and a motor. It was pretty tiny. But it fit in the back of our Honda Odyssey, and so I took the coaster. You would take it apart in 2 halves, and you'd stick it in the back of the van and drive it down, and we did a presentation, and the school liked it a lot, so I did 2 more presentations at our high school about it, and yeah, that was like the first iteration of the portable model roller coaster. So when I went to go for the next K'NEX model, I was like, okay, I want to be able to make this actually portable, right? Because the one before was kind of sketchy portable, and so I made the next one be actually built on like a platform that you could grab on both sides and move places. And the next event that I was planning for was Kings Island's Engineering Day. So I ran the model at Kings Island's Engineering Day a couple years ago. It was a 2-day event, and it ran quite well all day. The only problem we had was some high winds, because model roller coasters do not like high winds. It blows the train backwards and makes it valley in certain areas. But it was all good, because that was the first model that I started using PLCs on. So I was like, okay, well, I want to demo PLCs in this model, and so I also wanted to show a little bit about the alarms and stuff. And so we were able to show students a little bit about how a roller coaster will fault, and it was kind of interesting to see, because it wasn't me triggering the faults, it was the ride valleying in the areas. And I was like, well, guys, see, the system is performing exactly as it should be. We can look at it on the screen here. It says the train is has not made it back, and so at this point they would go out and do this, and it was a really nice learning experience, right? So then I was like, okay, well, this was cool, but it could be way cooler. So I decided to put more I/O on the ride, and I wanted to start doing more with alarms and stuff like that, more with the PLC. But at the time, I only had this tiny little Micrologix PLC, so I had to like step it up a little bit, and I installed a a Slick 500 PLC on the next model, and that one was that one was pretty cool. It had a very similar layout to this one. It was the first one that I ever tried a transfer track on, and the first one that I ever attempted a little bit of 3D printing in there. So I did a bit of 3D printing on my second model, and it looked like Intamin track. It had a cable lift hill. It was pretty cool. And I think I had something like 25, 30 sensors on it. And that was also the first one that I tried a friction braking system. And that was a pretty cool proof of concept for this model, because this model has like the second gen friction braking system on it. And so, yeah, so that was kind of how this thing like evolved. And then of course, at the end of the model with the friction braking system and the transfer track and the 3D printing one, that was the one that I demoed for the University of Cincinnati, and that's where they kind of got super excited about this thing. We're like, okay, yeah, we need one of these. That's pretty cool. So, yeah. Does that answer your question?
Yeah, all right. One more, and then we'll run around and take a look at things. How long have you been working on this iteration of it, and what were the milestones along the way?
Yeah, so this iteration has been going for about 2 years now. I started in fall of 2019, and it was just after I had gotten back from Walt Disney Imagineering, and I was all hyped up on building, cool roller coasters and stuff like that. And so I sat down and I was like, I don't need K'NEX. I can really go all out on this thing, and I was like, all right, I'm going to do this entirely 3D printed, with the exception of the track, because I'm not a mechanical engineer at heart. I'm a computer engineer. I love the technology. So I was going to skip over the whole developing a train and developing, the track and stuff like that, and just go with a pre-built track design. So the track on this thing is CDX Blocks track from Coaster Dynamics, and then the standard stock CDX trains. And so that saved a lot of time there. But I was going to design the model in computer-aided design software. So I was going to use No Limits to actually, lay it out and stuff like that. And one of the things that I kind of figured out over the years about building models is that they don't perform exactly the same as real roller coasters. So when you go into No Limits and you're trying to figure out how to, make a model roller coaster, it's not guaranteed to work because the physics don't scale perfectly, right? Like you can't build a one-to-one scale, like a scale model of Millennium Force and expect it to go. I mean, you could, but you'd probably have to do a lot of work on the mechanical side to get it to work. So I was using the stock CDX trains, so I actually designed a little test bench that allowed me to figure out the constants that you throw into No Limits to say, here's the new friction profile and here's how it's going to work. So that I knew when I built it after 3 months of printing that, it's going to work. So once I finished the design in No Limits, I brought it into Fusion 360 and I designed all the track pieces and the whole tabletop, and I designed the electrical system and all that stuff. And then we started printing, and we printed and printed and printed and printed and printed for like 3 months. It was crazy. We had like 3 printers running like almost 24/7. It was insane. And that was, the time that COVID-19 hit. So now we're passing parts between each other because I was working with my advisor on printing everything. And so, we're printing, and then I'm getting to the point where I'm going to do the table. And one of the biggest challenges of the model was actually the tabletop. The tabletop was supposed to be, CNC machined. So I was supposed to take it into campus, and I was going to lay it down on this 4x8 CNC machine, and I was going to cut all the holes, because I had designed the whole model so that you could, cut the holes in the table and then, bolt down the supports. Well, didn't happen because of COVID, right? I can't go down to campus because we're not letting anyone down to campus. It's all closed. So I came up with this idea. I don't have a plotter either, so I can't make like a giant full-scale drawing to put on top of it. But I was like, that's the only way to do it and make sure it's dimensionally accurate. So I printed off like 100 sheets of paper and then cut them all perfectly and laid them down in a giant grid on top of this board, right? And then went through and hand drilled like 250 holes or something like that, and yeah, it was a fun time, but it came out perfect. I was super happy with it, with the end result. And then of course, you know, I built it, put it all together over the summer, and then that was about the point that Rockwell Automation had gotten all of the electrical stuff in, and I you know, installed the electrical system. And over Christmas break this year, I think I spent oh my gosh, just an insane amount of hours programming this thing to make sure that it works perfectly. And now we're in the final stages of the project where I'm documenting everything. I'm writing up a maintenance manual so that because at the end of the day, it's not me who's going to be using this thing, it's the university that's going to be using it. So someone who has not designed this model needs to be able to maintain it. So it's literally like the full project life cycle that you would see at an amusement park coming together here for the end, because, you know, then we're going to have a training day coming up here soon too. So we're going to be training on how to run the model with as I hand off the model to the end users, and then they're going to take it away and do with what they want to with it. So it's going to be neat to see what happens with it in the end. So yeah.
All right. So what's next for you? What are your plans after this model?
So my plans as far as the models go after this one is to start developing the next one, of course. Like, I want to get more into the whole 3D design thing. I had a great time, like, actually modeling everything. I want to make my own trains next for it. And then, of course, get more advanced in the control system. So you never know, you might start seeing some interesting track elements that, you know, are closer to rides that you see on, you know, like Hagrid's and that kind of stuff. Some of those, like rides like Hagrid, absolutely fascinate me because that thing is just a machine, the way it runs. It is amazing. Like, you know, the super short dispatch intervals and the amount of technology that's involved with the track switches and drop tracks and all that. And I want to see how well I can replicate something similar to that on a small scale like this. So yeah, getting more into the technology of ride control systems, less than, you know, more so than just like a block system, right? So yeah, that's kind of what's next, I guess. And then of course, you know, getting into the amusement industry at the end of the day, like that's my end goal. My end goal is to really work on actual ride control systems out there. So hopefully one day when COVID-19 is a distant memory, I'll be out there working on the real stuff. So yeah.
All right. Well, thank you very much, Jared, for sitting down and explaining this to all of us, and good luck with your next model.
Yeah, thank you so much. Really appreciate it. I had a great time.
My name is Dan Pritchie. I am a 2019 mechanical engineering graduate from Iowa State. I spent my time in quarantine designing and 3D printing the world's first 3D printed launch roller coaster.
All right, let's check it out.
Just incredible. So where did this idea come from? How did this come to be?
From a super young age, I loved roller coasters. Playing with K'NEX and Lego roller coaster were my childhood. So 3D printing my own one was just kind of the next iteration. I remember seeing Matt Schmozer print my ride's Boomerang. It was I believe the world's first 3D printed functional roller coaster. And with my background in 3D modeling, and I knew that I wanted to do that someday. So I eventually conquered the challenge and did it myself.
Awesome. So tell me about, your engineering journey through high school and college and getting to work in the industry.
Yeah, so ever since I was super young, I knew that I was going to be an engineer. My dad was an engineer, so from a very young age, I was instilled with the problem solving and just general engineering curiosity for how things worked. So going to Iowa State after having an engineering class in high school just really solidified my plan, and going to Iowa State knowing that I wanted to pursue a career in the amusement industry. I was given the opportunity to intern at Premier Rides in 2018, where that was just the time of my life where I got to see the ins and outs and the background of what actually went on behind the scenes of roller coaster design, which was just the coolest thing to me. So then coming back and finishing up my time at Iowa State, you and I started the Iowa State TPEG group, which is just an extremely rewarding experience. And I think that it's so important for kids to have that opportunity that we didn't have, to go to IAAPA and ASTM and have these experiences and opportunities from their freshman year.
Tell us about the version of this launch system that you designed before going for this full-size version.
So in 2019, I made a K'NEX roller coaster that was also launched, and this was extremely important for as a stepping stone to moving on to the 3D printed one. I essentially just reused the launch mechanism that I did in the K'NEX one. I 3D modeled it and basically just miniaturized it, and it worked even better because all of the parts were custom modeled and fit together way better than K'NEX ever could.
So what does this new model have with it?
Yeah, so the 3D printed one, it's complete with station gates, drive tires, brake fins, transfer track, and obviously the launch system that retracts and launches all on the push of a button.
All right, so tell us about the train. What went into that train? How did you design it? How did you build it?
Yeah, so obviously the key to having a functional 3D printed roller coaster is having a functional train. So over about a year and a half, I think I spent kind of on and off doing different train iterations. And at the end of the day, the one that's running on the layout is the third iteration, where it has come a very long way with understanding and learning all the degrees of freedom that are needed for a functional roller coaster train.
So the structure and the track design, how did you make that and assemble it and put it all together?
Entire model and layout was designed in Fusion 360, which is very similar to SolidWorks, for those who are familiar with that. But the layout was initially made in No Limits 2, which is a roller coaster simulation software. Then the layout spline was put into Fusion 360, or everything that supports the station, the track, the gates, brakes, everything you could think of was all modeled in Fusion 360. As all of those components were being modeled, I was able to 3D print them within a few minutes to hours after designing them, to ensure the proper fit and to make sure everything went together the way that I wanted to, the way that it was designed in the model. This was extremely important to verify design feasibility and just make sure that everything was going to work the way that I wanted it to. So after everything was 3D printed, assembly came next. I put all the supports onto a base. Everything was screwed in from the bottom, so it was all held together nice and tight. Track sections went on next, and some PTFE tubing snapped onto the track to make everything nice and smooth. And then all of the smaller things like the bungee went on, the station went on, the brakes went on, train finally went on, and then test run started after that.
right, so tell us about the control system. What did you use, and what is it doing in order to make it, operate?
So for the control system of the ride, in Arduino, tells all of the servo motors what to do and when to do it. With my very limited coding knowledge, I had it set up so that just on the push of a button, the train would cycle onto the next part of the ride. So button press, gates open, button press, drive tires, moves on to the launch track, button press, launch tracks, button press, launch, and then yeah, onto the brakes and into the station again. Cycle repeats.
Very simple system, just hit a button and it goes.
Yep.
So if I wanted to build a model of my own at home, what should I do, and what do I need to know?
So I think the biggest thing is when you're just starting out, just having that perseverance to not give up, because I've known a lot of people that have started and just kind of given up within a week because they find out it's a lot harder than they think it is, and the best advice that I can give is just to keep going. It's not going to happen overnight. It's going to take iterations, and it's going to take frustration. And but I think the biggest thing is it's so rewarding at the end of it when you spend all of these hours trying to get the design just right, and then you print it, and then you see how it works, and see how excited and impressed other people are. It really just makes it all worth it. So you definitely can do this on your own, but it's a lot more rewarding, and I think the end product actually comes out better if you're able to find a community of like-minded people to do this sort of thing with. I've been lucky enough to find a group of, a lot of guys that are into the same thing, and we all share our ideas and our knowledge and our passion together. And I think when you can really see what other people are working on, and taking ideas from other people and helping other people out, it makes the entire experience so much more rewarding than just building a model roller coaster in your basement by yourself.
All right, so what's next for you?
So yeah, after finishing this most recent layout, I'm not stopping there. I've already begun designing new ideas and printing them out. So feel free to follow that progress at Instagram at 3D_coasters.
Well, thanks so much for sitting down with us and telling us about your process, and hopefully some people will be inspired by you, and we'll see some awesome new models yet to come.
Yeah, thanks so much for having me. It's been awesome talking about it.
All right, let's get back to the teams that are competing in the ride engineering competition.
Hey everyone, my name's Gabriel Russ. I'm an electrical engineer with Irvine Andre Engineering, and I create the computer-operated systems that control and safeguard roller coasters, amusement park rides, and all sorts of other attractions. Or in other words, I'm a professional roller coaster tester. That picture's from me and my boss Ann Irvine when we were doing our commissioning of Steel Vengeance up at Cedar Point. So I'm here to give you an insider's view of how we bring roller coasters to life, how I got here, and what it takes to be an industry professional. So how do we make a roller coaster safe? A big part of that is we make them computer controlled. That removes all sorts of human error from the equation. It also allows us to do all sorts of monitoring and special programming to create an intrinsically safe ride. So what makes a roller coaster safe? We have industry-wide safety standards that we have to follow, and these are created by panels of the most experienced professionals. We design to very high safety levels. If you've heard of SIL and PL, we designed to SIL 3 and PLE. These are the highest levels of safety and reliability. We accomplish that through the use of things like safety processors. These are ControlLogix PLCs from Rockwell Automation, and as you can see, there's a pair of them. These work together and check each other during the ride's operation to make sure that everything is operating as it should. We also use Safety I/O, so cards like this you'll see all around the ride. This is what reads proximity switches, causes brakes to open. All of the critical systems are controlled by these parts. We also use a variety of other parts. These are safety relays. Rockwell Automation makes it real easy. If you see red, generally it's a safety rated part. We also use safe torque off with our drives. That's a way of making sure that a drive is not going to suddenly start moving without the proper authorization. We specialize in simulated danger, and we try and make incidents as rare as possible because any event will become very high profile. If you've ever seen the news, you'll see it makes the news just for having to take people down off the lift, or even sometimes if it just stops on the lift. And we don't want to have any incidents worse than that. And we've been doing good work there because the actual risk at a fixed site park is 1 in 15.5 million. This is from a 2019 IAPA survey, and as you can see, over the last 20 years, the injury rate has been trending down, and we hope to keep it that way. So the main way that we accomplish that is through block logic. It's very similar to how old railroads used to operate and still do. That's how we safely are able to run multiple trains. And we design rides to stop everything if there's an error or it sees something that it's not familiar with. That can be accomplished by trains stopping out on a brake run or stopping on a lift. It's not necessarily a computer glitch, it's the ride seeing something that it doesn't like and responding to it in a safe manner. The overall view of block logic will look something like this. You'll have the ride separated into a few blocks. Things like the station, the lift, the ride course, and the transfer track are generally all examples of blocks. The ride will have a way to stop the train at the end of each block, as well as a series of sensors, sometimes at the entrance and the exit, or just at the exit, so that the PLC is able to know where around the ride vehicles are located. And the way that we program these, if you've ever heard of computer programming languages like C, we go something a little more basic than that. All the movement and computer-controlled safety comes from the PLC. One of these, as you can see, this is from another one of our attractions. It's called a programmable logic controller. Inside, it's running ladder logic, which is the descendant of old relay logic from the 1940s. We still have it. We've just computerized it so that we can run way more logic on these processors. It's called ladder logic because the code looks like the rungs of a ladder. You'll have hundreds or thousands of these, and the PLC, as it's running, it's just constantly stepping down the line and checking each one. And the way it operates is, as you look at a rung, you check if all of these bits are turned on and it's able to get through the rung, then the circle there, that bit or that output will be turned on. And these are able to run extremely fast, generally between 10 and 20 milliseconds a cycle. So we're constantly running this logic, constantly checking everything for proper operation. The other neat thing with ladder logic is you can create custom instructions to simplify your programming. This on the right is one that Rockwell Automation provides for us. This is a redundant input. That's how we look at the power switch. And this is one that we've written. So this lets us greatly simplify and speed up our programming, since a lift stop button is very common, and that makes the programming of it run a lot faster. So the inputs and outputs are sensors and our actuators. Here's a general overview of the way we do motion control and the way that the power flows to a motor. So you'll generally have some form of input protection. This could be a circuit breaker, it could be a fuse, just some way to make sure that you're not getting too much power through. Then in some cases you'll have a contactor before your drive, or you'll just have a drive, and that drive will have safe torque off signals. These drives are designed so that if your safe torque off signal doesn't have power to it, the drive is not able to apply torque to the motor. That's an extra level of protection to make sure things don't start moving when we don't want them to. And then the output of the drive will go to the motor. You'll also have monitoring on the motor to make sure that it's rotating at the rate that you're expecting it to, that nothing is going where you don't want it to. And that's the main thing that we design for. You always want to have feedback, and you always want to have multiple ways to stop things from moving if you detect something that doesn't look quite right. The most common input sensors that, if you've ever been to a theme park, you've seen these, are proximity switches. These use inductive sensors to look for metal. It can be a brake fin, it can be a wheel assembly, and that's what the PLC uses to detect where on the track the train is. These are from Paperl and Fuchs. There are many brands of proximity switches. Turk makes some, Allen Bradley makes some, SICK makes some. They're very common through the industry, although I think most people are familiar with the green Pepperell and Fuchs ones. We also have the ride operator panel, and that's how ride operators give commands to the PLC. You'll generally have all sorts of input buttons there, as well as indicator lights in some of the buttons that the ride is able to tell the ride operators what's going on. And of course, in the center, you'll also have a HMI, or human machine interface, and this is a input and output screen, so you can display all sorts of data for the ride operators, for maintenance staff, and for debugging during commissioning. The outputs of the ride, these will be things like chain lifts, magnetic launches, and your pinch brakes. So the most popular output that we seem to get a lot is linear synchronous motors, or LSMs. These are ways to get really a lot of power into a train, get it moving very quickly. You also have linear inductive motors. Those are slightly older, but you do see them a lot. And cable launches. Those can be powered by motors, by hydraulics, or just by a big block of concrete dropping really fast. Coaster brakes, originally, they were hand controlled. You'd have a ride operator with a big lever, they'd pull it, and you'd stop the train. It's not exactly safe because now you're relying on a person to control your motion. So now we're getting into computer control of them. So pinch brakes are the most common. These use air pressure to pinch on a fin on the bottom of the train, and that can slow the train by pulsing it, or by holding it shut, you can stop a train. These are always designed fail-safe so that if you lose air pressure, you'll always be able to bring a train to a stop. And magnetic brakes, these are a slightly more recent addition to roller coaster parts. These use magnets to convert the velocity of a piece of metal into heat. So by having a metallic fin move through these magnets, you actually generate heat inside of the fin. It's a very fascinating bit of technology there. So some coaster safety information. So we start the creation of these control systems sometimes years in advance, and that is creating drawings, writing the code, getting everything ready for when we first go to site. We have panel shops that build these cabinets for us, and then we ship everything as a unit. The park installs it, and then we come out for our commissioning. This is a typical control systems drawing. You'll have your push buttons, and this is actually one of these input cards. So this is a way that the electricians can know how to wire up the panel, and that the maintenance staff will be able to maintain the panel after it's been installed. Before humans ride, we weight down the train to simulate heavy loads. As you can see here, this is a water dummy. You fill it up with water and it weighs about as much as a person. That way you can make sure that the forces on the ride are what we expect. So how did we get here? We generally try and say avoid being completely focused and I want to design roller coasters, because there are very few, unfortunately, positions like this in the world, but there are a lot of other very awesome and interesting jobs too. Before I started working with Irvine Andre Engineering, I used to work at Rockwell Automation and American Electric Power, back when my hair was a little bit shorter. An engineering degree is very versatile. You can take your skills to many locations. However, if you're coming to a thing like this, you're probably not going to be dissuaded that easily. So here are our general tips. We say always keep your goal in view. You never know where your path is going to take you. When I started working with those other companies, I wasn't sure if I was going to come back to the industry. But I saw it as a good path. You know, AEP is a great company, Rockwell is a great company. We wound up coming back in. Meet as many people as you can in the industry. All of us do love meeting new people. We like talking with people. Our job is to have fun, so we try and have fun with others. If friend us on LinkedIn, shoot us messages, we all appreciate it. Live your passion. We love to see passionate people join this industry. We don't want, you know, if you're in this job, we want you to really, really love it. Look for opportunities and don't be afraid to take risks. You're always going to be learning. You never are going to be done, and we love seeing people who will take those chances, because that's where you learn the most. Great ways to get in: networking. You know, like I said, reach out to all of us. We do love talking with people. Coming to events like this is very helpful. Go to IAAPA. This is a convention down in Orlando, Florida, if you haven't heard of it. It's a wonderful time. I believe they are doing it this year. Learn body language reading skills. Speaking as an engineer, I'm absolutely terrible at body language. I used to be much worse. It's something that you genuinely have to practice, especially as an engineer. maybe it's just me, but I'm terrible at human interaction sometimes. Be patient and be humble. We love to see people who are raring to go, and look fear in the face and know that you can handle it, because all of us are rooting for you, just like that. And if you stick with it, dreams can come true. This job has taken me literally all over the world. It's given me many interesting challenges, but I've enjoyed every moment of it. And I think this is where we'd open it up to questions if this wasn't pre-recorded. Feel free to contact us on Facebook or email us. My email address is down here at the bottom. And there is our Facebook page and our website. Thanks very much. Ta-da! And bye.
Hello, we're back to do another downtime highlight, this time with the Ryder Riders. Paige Ryder, can you hear me?
I can hear you.
Awesome. All right, tell us about what kind of downtime have you experienced today?
Let's see. I think I have reported 4 downtimes. 2 of them, interestingly enough, I keep saying were caused by this 16th-inch hex key. I don't know how well you can see it in my camera, but it's very bent, and the ends of it are very stripped. So last night when we were trying to tighten down all of the set screws in our shaft collars, to tighten everything up, I must have tried over torquing some things, and both sides of this are now stripped. So it's very, very challenging to get a nice, good tighten on any of our shaft collars. So 2 of our failures, one of them was me seeing that something had come loose, stopping the ride so I could tighten it. The other one was more preventative. I was listening to the sounds of the motor, and it sounded like it was getting a little bogged down. So I just preventatively, again, shut the ride down, went and tightened up a couple things, and it seemed to have cleared things up. So that was 2 of them. Let's see. The first one I had, which was actually right at the very beginning of the competition. So we were, about to start, and then, I set everything up, I pressed go, and I'm like, why is it not working anymore? Why does it feel like my ride is struggling? Silly me, I hadn't put 2 and 2 together that I'd been doing testing with fewer riders, fewer starburst in my ride, and needed to compensate for the different load. So I did some testing. I changed the PWM limits of what was being sent. what I ended up doing, because it was kind of just me by myself, I ended up taking out some of the riders, and I am running at lower capacity than I'm supposed to. But that's allowing me to run the ride a little slower. It just kind of keep it a little more under control. So that was that. And then the most tragic one was we had a rider ejected from the ride, unfortunately. I have kind of stand-in restraints that are essentially bent safety, or not safety pins, paper clips. And one of them must have worked its way loose after like 4 hours or so of the competition, and one of the riders just took a tumble. But luckily that rider's okay, so it all ended up being fine. But yeah, probably wouldn't be good with a real rider. So those are my 4 downtimes that I had to take care of.
Good to hear that the rider is okay. How many riders do you have on your ride at any one time?
So it's kind of been varying throughout the day. At like the times when we rotate, the riders and stuff. Right now, I think I only have maybe I'm pretty low right now. I think I'm only at 3. But earlier I was running pretty good with 6 or so. Again, I've turned it way down for what the motor can do. I'm sending only about 1/5 of what its max PWM signal is. But again, I'm in my house and don't really want to accidentally fling riders at my TV or at my head. So that's something I need to work on in the future, is better rider management. So yeah, definitely below capacity right now. It can hold up to 30. And we actually do have more seats so that the ride can hold up to 60 all at the same time. But 30 is a pretty comfortable number.
And you have extra spare seats if any of those parts malfunction, you can replace them with the spares that you have.
Yep. Got lots and lots of spares. One thing that I was thinking I might need to replace was the arm that comes out and runs into the ramp and kind of throws the riders into the air. We anticipated that being a kind of wear component, but they're actually doing great. That's one of the components that we take a look at on the hour and make sure they're still doing good. But yeah, those have been holding up really, really well.
All right. What are other situations that you anticipated could be, problematic throughout the day, or something that you're looking for to make sure that it's operating correctly?
Yeah, one of the biggest ones, and we kind of did have to deal with it already. The most critical area is making sure that the arms are securely attached to that central hub. So we're keeping a really close eye on the spacers and the distance between the arms, the spacers, and the central hub. That's something we're keeping a really close eye on, and ready to tighten things up if we need to. Another thing that I had anticipated might cause some issues, but it actually has not, thankfully. We chose our design strategically well, I guess, was the counterweight. It's like a big ball of silver littler balls. I was worried at first when we were putting everything together that it might get in the way or run into that ramp. But we ended up being able to put it far enough out that it never contacts the ramp or anything like that, which is great news. Definitely good for our DFMEA. And then another thing that I was worried about was the ramp is a 3D printed part. It's taking a lot of abuse. It's essentially getting smacked over and over and over again by a rod. So I was just curious to see how that part would hold up. And there's a part of it that's got, I thought it looked like some wear on it, but Alex actually thinks that what's happening is as the ride comes around the corner, the little rods are scraping off some of the plastic on the side of the ramp, and then the next time it comes around, it deposits that onto the ramp. So it's like there's a little spot on the ramp that's got some extra powder on it that's been redistributed from the ride. So there is some wear happening on that component.
All right, so you have a ride physically in front of you. How does seeing it operate and you know, getting through this 8 hours is a long time. You're learning things along the way. How has that surprised you compared to when you were building your DFMEA, your design failure mode effects analysis, just on paper without that ride? How does that compare to actually testing the ride?
Oh, yeah. Because when you're sitting there trying to fill out the DFMEA, you're trying to think of everything that could go wrong, right? But gosh, it's very hard before you can like fully see how the ride's gonna come together. Unless you have like the most amazing CAD model that's like super duper precise and models everything perfectly. I have a hard time being able to come up with like all the failure modes. So definitely having the ride, seeing how it reacts to all the different, you know, impulses that it's getting, things like that. I'm definitely seeing decisions that we made that are okay, but can be improved, that maybe looked fine on paper. So it's definitely very rewarding to have, even if it's not the full prototype, a prototype. Like that's why we did like Lego models. I don't think we would have been able to get to this model we have without having done iterative Lego models before that. That really helped us get there. It would have been hard to jump straight from a piece of paper to what we have. So prototyping is good. Even simple things.
All right. Well, thank you very much for joining us, and good luck making it through the next 2 hours of operation, rounding out our day here. Thank you very much.
We are getting there. Thank you for facilitating and asking all these awesome questions. See you later.
Yep. Good luck. And join us at 3:15 for our feature on Matt Schmatzer. Thanks, everybody.
Hi, my name is Matt Schmatzer. I work professionally in the automotive industry as an engineer, and on the side, I design and 3D print model roller coasters.
All right, so when you were in college, tell me about your engineering journey and going, reaching graduation. What was the world like for you?
Yeah, it's all very intimidating, and everyone's, trying to progress through college so they can ultimately land the dream career. And as I was going through, I knew I was going to be a mechanical engineer. I loved to tinker. I loved everything about mechanical engineering. And the one thing I wasn't sure about was what I was going to do with that degree. I knew I wanted to be, in some capacity in the amusement industry, either designing rides or maybe working in parks, managing, ride installations and stuff like that. But it was kind of loose. As I eventually graduated, I, had to come to the realization that first I need a job, first I need to get experience. It doesn't really matter so much as, where my path starts, as much as I know where my end goal is. As long as I get there in the end, that's all that matters. So, as I said, it was kind of intimidating at first, but as I graduated and then moved on to, my career, I just had to take it one step at a time and not get too overwhelmed by everything going on in the world.
All right, so tell me about your first 3D printed coaster. What was that process like? Where did that idea come from?
Yeah, absolutely. I think it kind of stemmed back in 2016, 2017. I was really into 3D printing. Actually, when I was doing my undergraduate degree, we had to use 3D printers, but they were like the big SLA machines that you really can't get in your house. And at the time, like 2014, 15 time frame, 3D printers became like a cool thing, and the rep movement was coming where you could 3D print a 3D printer and then make more 3D printers from 3D printing. And so I thought that was so cool. So I got my own 3D printer. Actually, I got a couple of them, and I was 3D printing like knickknacks and stuff. And I was like, this is cool, but like everyone wants to do like the functional print and prove that 3D printing isn't just like some toy. So I took my passion for roller coasters and, was playing around with 3D printing tracks, 3D printing trains. And I was like, well, there's all these people before me that have made working models using, their craftsman abilities, like gluing stuff together or welding, brazing, all sorts of other methods. And I was thinking, well, how do I put my own twist on this? And at the time, back 5-6 years ago, I didn't know of anyone that was 3D printing roller coasters. So I was like, I'm going to make a 3D printed model roller coaster that works. And I just decided to start out small and easy, just pick a small ride that's got a small footprint, just test the concept, which I think I picked the wrong ride for it as far as, all the mechanical bits. I basically did in Vertigo at Kings Island, and it had its own design challenges with it that I wasn't really ready for. I thought it'd be a simple project where I could design some tracks, design some trains, and see if it works. And after I think about a year and a half, we finally got it working. And I took it around showing other students. I took it back to Purdue where I graduated and showed their TPEG club, and everyone loved it. And the first question is, well, like, how long did it take you and what challenges? And there's just so many. So that was the first one. And ever since then, I've just been hooked.
All right, so tell me about the Model Steel Vengeance project. How did that come up? And what were your initial steps on that project?
Yeah, so it's a very popular project as it's gotten a lot of publicity, and everyone does ask, like, who approached who as far as the park contacting me or if I went to the park. The truth is, and I love the stories, I actually went to Cedar Point because I wanted to get a picture of Vertigo next to the real one, and I wanted to see if I could take the model and get it next to the actual ride. And at the time, Kings Island, I think, was in a transition where they didn't have a public relations person. They do now, obviously, but back 5 years ago, I think they were just trying to find someone. So I didn't know who to contact. I sent like 2 emails. They went nowhere, and I was like, well, this is kind of a bummer. Like, I know they would love to host me showing it. So I contacted Cedar Point. Obviously, it's the sister park under Cedar Fair. And I just said, hey, I'm just looking for a contact at Kings Island. I just want to get a picture of my model next to the real one. Could you point me the right way? They replied back saying, oh, yeah, we'll forward this, but we want one. And I was like, okay. And at the time I knew they were working on Steel Vengeance, and I was kind of hoping like, hey, maybe that'd be kind of cool to work on. But at the same time I was terrified, like, please don't make me do that one. And they're like, oh, well, we have this new ride coming out. And I was like, oh boy, here it comes. And so they asked if I could make a working Steel Vengeance. And I said yes, without even thinking about what it would take to do that, because I was like, from my perspective, thinking, wow, I get to work with Cedar Point on a model of their new awesome ride, because every time they come out with a ride, it's bigger, better, faster, awesomer. So and I would just regret, if I didn't. So that's how that transpired. And next thing you know, they were asking me to put a proposal together. And the one funny thing is I wanted the model to be huge, and they said, Matt, you need to sell down, let's make it small. And so we basically agreed on the size based off it needed to fit in their museum. And that is the tale of how that happens. So it's pretty cool. If you prove and can show and document that you can make these working models, and people will get interested, and you can get cool opportunities.
So a model that takes up half of a room is a small model.
So as you work on these models, you will quickly find out that the scale is tough to work in when you go down to these smaller sizes. And for let's say in Vertigo, the scale that I was working with, it worked because let's say if I was working at 1/12 scale, that just means 12 tables, then I have the full length of the actual ride. Well, when you're working with Steel Vengeance, it's terrifying when you're like, okay, this ride is already massive. It's its own hyper hybrid. So no matter what scale I'm working at, it's going to be huge. And the amount of track length. And obviously you're working with Cedar Point, so it's going to be this huge, awesome ride. It's not going to be some little, carnival ride. So I like to work with bigger scales because then you can get a lot of detail. You can troubleshoot issues. There's a lot more room to work with. They want it small because obviously they can't have me take up half their park with a cool model. And when you think about the time to build, going from one factor, scale to another isn't much of a leap because you're still going to have to build every same bent, the same number of bents. The only thing is the material cost. But when you're dealing with balsa wood and 3D printed parts, if you're just going up a little bit, the cost isn't as much as the time you're going to spend troubleshooting issues and trying to debug these itty bitty parts that you can barely see. So in my mind, it makes more sense to go bigger, even though from what you're saying, it's when you go bigger, it's just going to be huge. It's going to take up this room. But that's not on me. I'm just building it for them. So let them figure out where it's going to go. So that was at least my perspective on it. I wanted to go bigger. They wanted to go smaller, and then we met in the middle. And I think we settled on a good size. Now that I think about it, I wouldn't want to go any bigger just because it's just bulky. But when you go and look at it, it's just the spectacle of wow, that's big.
So can you walk us through some of the components that go into a roller coaster, or in this case, a model roller coaster? So what are the different sort of vocabulary terms, and what are the pieces that build up into this coaster?
Yeah, so at least from the model standpoint, I like to be as accurate to real rides as possible. So I've done a lot of benchmarking as what's actually used in the industry. As I said, I'm just imitating the industry. I'm just following their lead. So as far as vocabulary and the Steel Vengeance model, you have bents, vertical bents for your vertical posts, and then you have the ledgers and ribbons, cross ties, track. So all the normal vocabulary you would use in a real roller coaster, I would apply that to the model. You have up-stop wheels, side wheels, road wheels. That's for, brakes and chain lift, chain dogs. All the same vocabulary, but now just take that and then shrink it all down. And now either 3D print it, laser cut it, CNC route it, use whatever is in your makerspace to recreate that in a smaller setting. So the vocabulary mostly is the same, and the construction is relatively the same. As far as you start from the ground, you get your foundation, you get your, the footers are all laid out, so the actual position, and then you kind of construct it the same way. You don't have to when it comes to model building. You can make your own rules. Instead of a crane, you have a hand, so that's nice. but I like to be as authentic as possible. So like on the Invertigo model, I 3D printed the track sections almost like the real ones, where it was individual track sections and they'd bolt together with tiny M2 fasteners, and they would bolt together just like the real thing. And I tried to follow the same procedure on Steel Vengeance, although since Steel Vengeance was a different scale, I had to use glue more so than fasteners, but the assembly is still the same. You have to build your structure first, your supports first, and then you can put the track on top of the structure or supports, whatever you're dealing with, and then you design the train and go from there. So it doesn't have to be in that order. You can design the train first and then go and do the track. There's no right or wrong there, but that's at least what I did.
So tell us about the first attempts at both the Invertigo and the Steel Vengeance model. What was that experience like? How well did it work on the first try?
Yeah, so as an engineer, you need to be a problem solver. And with these, millions of problems come up. And they're always the ones you're not prepared for. So like you'll think like, okay, I'm going to deal with this, and then you'll work through it, obviously. But it's always the ones you're not thinking about that come to sting you. And each project had their own set of problems you had to deal with. So let's talk about Invertigo. That was the first one I've ever done. And like many people I've seen follow, you would 3D print like the running rails or the running surface. You'd 3D print that. I learned quickly that is not the way to go, as it's very inefficient with your wheels running over a layered, as a 3D printer prints, it prints in layers. And if you're running a wheel over that, it'll just go like it'll vibrate, it'll bump. So I 3D printed the rails first, and I was like, that doesn't work. So I was like, okay, I'll sand them. Then it's inconsistent. Then you have like wavy rails because it's hard to sand a curved object. So I was like, all right, we're gonna ditch this. We're gonna do like what K'NEX does, where you use like a tube. Well, that didn't work because the tube was too flimsy. Well, we need to get a harder tube, a more rigid tube. So you get a rigid tube, and then you find out that's the solution. Cool. But then you run into other problems. Well, now my train doesn't go around the whole track. Well, why doesn't it? Well, I'm not carrying the momentum of a real train. When you think about a real train, it might weigh 1,000 pounds, might weigh 2,000 pounds, might weigh even more when it's loaded with people. Then when you scale that down, it's like, well, my train is like ounces. So I need to get that weight to make my momentum carry through the whole ride. Well, how much weight do you put on? Well, now I put all this weight on. Now my track is flexing because it's plastic. Well, see, the problems compound on themselves. And you can plan for it, but you have to be ready to work through it. So it's like, okay, now my track is flexing. Now I got to go back and make sure it's all, put together correctly. Well, now I have this heavy train. Now my motor isn't sized properly to lift this heavy train up the hill. Well, oh my gosh. So now I got to go find the proper motor to use for my lift. So that was the struggles for Invertigo. Steel Vengeance, so I learned all that, and I was like, I'm going to apply that for this model. Worked great until I ran into other problems where now I'm working at this tiny scale. My track is like half the size of what I use for Invertigo, which I wasn't ready for. And so I was, challenged with this new track gauge, which I wasn't really ready for because all the hardware I used on Invertigo didn't cross over to that new scale or, design as easily as I would want it to. And then Steel Vengeance also had a new constraint that I was not, ready for, is time. Where now I have a time constraint. It's like now, not only do you have to make this and work, but we want to have it by opening day to showcase the new ride, which makes sense. I was under the gun to get it, ready in a certain timeline. Which when I had Invertigo, was kind of like, I can do it whenever. And if I run into an issue, it's not the end of the world to sit on it and think about it for a day. Whereas Steel Vengeance, it's like, okay, we need a solution now, and we need to be working towards the correct solution. And sometimes you'll learn that going forward with a direction is sometimes better, even if you know that it might not be the right direction. You just need to keep moving forward, or just keep moving. If you just sit and think about it, you could think about it forever, but you need to have at least something to work for. So each project had its own challenges, but as I said, it goes all back to being an engineer, being a problem solver, and then having the discipline to keep moving forward even though you might not know the solution.
All right, so how has this changed your view on ride engineers and the people who are doing this on the full-size ride? How has your mindset and experience with that type of problem solving changed through this process?
Yeah, so model making has definitely influenced the way I think of industry professional and how they have to problem solve in the real world. So, and they probably have a much more challenging job than me making models. My models, you know, if it doesn't make it through the course, I just kind of push it through and I'm like, that's good. They have to get a crew out, they got to hoist it, and it's just time, labor. They don't want to deal with that. There's all these other things that you don't really consider with model making, like safety. You don't have to worry about the safety of your people riding your ride, whereas with the model, no one's riding it. So that's kind of a factor, a big factor, probably one of the most important factors that you don't even have to worry about as a model maker. So when you take that into account, I think, you know, safety is probably the number one priority in the industry. So they have to take it very seriously, and that in itself is just, you know, a job and a career of its own. So you get the you know, the benefit of not having to worry about that with model making. As far as engineering and structural engineering goes, you know, when you build a model, you can do physical testing really easily. You kind of set up a model and you can see if it bears the weight, if it bears the load. Okay, it does, great. But when you're in the industry, you can't just go and make a model for everything. That doesn't financially make sense. You're going to want to use the CAE tools to simulate that dynamic loading, the static loading on your structure, and save money by not having to go and physically test these things. You want to analytically test it. And that's why you get paid the big bucks as an engineer. You're going to develop the calculations to then go and simulate that dynamic loading on your structure, so you don't have to go and physically test it. And then there's the manufacturing aspect of it too. Now you have to fabricate your track and make sure it lines up with what was designed in the CAD software, which 3D printing's easy. You basically design it, 3D print it, and the 3D printer is your manufacturing team, so to speak. Whereas it's not that easy in the industry because you're dealing with steel. They don't have giant 3D printers yet that will 3D print your track for you. So there's a lot that there's so many different aspects. And I think the model building will, you know, introduce you to these topics. I don't think you get as much depth as you will in the industry, but at least you'll know what, you know, you're dealing with and what you have to deal with. So, that's at least my take on it from the model standpoint.
Cool. All right. So tell me about Print My Ride Detroit, and as an engineer and a maker, turning that into a business.
Yeah, so I really didn't have a plan. I just knew I liked roller coasters. I like making models. I even the only reason I got into the model business, I guess, is because I wanted to get into the actual industry, and I saw some of my influencers, which would be like Mike Graham and Chris Gray, and they built models and they worked. Well, at least Mike's did. Chris built just aesthetically awesome models that were, you know, just beautiful. And so I took inspiration off these guys, and I was like, wait a second, so they got in the industry and they made models. So if I make a model, put my own twist to it, like not just copy, but find a way to make it my own, then maybe I could use that to get into the industry. And the model making never really paid off because coaster models are cool, but they're just they're a nostalgia piece, or they're novelty. They don't actually bring in a profit to anyone other than, you know, hey, this looks cool. It's like art essentially. So unless you want to collect them, you're not going to be making a lot of money. So as I made these models, I quickly realized that. But there is value in making them because it shows you are disciplined, you want to follow through the project, you have connections within the industry of different people that want to, you know, make, you know, models of whatever their creation is. So I kind of used that. And at least when I was making my models, everyone wanted like, you know, a model of like a train or something, but 3D printing wasn't a viable way to do that. And then through these models, I was able to come up with my own idea of what collectible could be that people could then go and purchase. So as I said, I followed some of my influencers that I kind of looked up to, and did kind of what they did, but found my own way to make a, you know, a twist on it. And like, I'm sure some people know, like Mike Graham started Coaster Dynamics. Well, now I've actually partnered with Coaster Dynamics and have kind of like my own product within their umbrella. So, and I used my model making experience to kind of get that trust and those connections. And if anything I've learned is just keep following whatever, you know, path you're on. And as long as you're having fun, you'll eventually figure out a way to, you know, make money off of it.
All right. So For engineers who, especially now, may not be finding opportunities in the amusement industry, who want to end up in the amusement industry, what suggestions do you have as far as what they should be doing now, and what skills or experiences they should try to gain?
Yeah, I would say I have 2 points of advice. Is 1, be patient, and 2, keep on keeping on with whatever you're doing. So if you want to get in the industry, if you really do, you're going to obviously want to get in like yesterday. But maybe that's not an opportunity, or that's not an opportunity right now because outside forces are preventing that. Maybe companies aren't hiring, or they're looking for a certain skill set that you might not have. Well, then go see if you can educate yourself with that skill set, or just be patient until the economy or the state improves where now everyone's hiring. I would just say be patient. When I graduated, I wanted to go design roller coasters, but there wasn't really any jobs available, or my skill set wasn't, honed so that I would be, a candidate they would like. So it's funny because, as I said, like I just went down my own path, and I never let go of that interest, at least for roller coasters. And I kept, making models and staying engaged with the community, and always try to find new networking connections. And then 10 years later, like I'm working at and with parks, I'm working with manufacturers, I have display pieces everywhere, and it may not be designing actual roller coasters, but it's still in the industry, and I can still like celebrate that excitement. So it was all worthwhile there.
All right. What is the best thing about what you do now?
What I do now, so right now I design these coaster cutouts, which are laser cut wooden models of actual roller coaster trains. And what I love about it is they're popular enough now that we can go and design actual trains off rides that exist now, go to a park and say, hey, would you like to sell these at your park? And they love it. And the one thing I love is they really like the details we're able to capture in some of these models, which I just find so fun as an enthusiast, that I'm like, oh, there's like little itty bitty details that the general public might not pick up on, but we as the enthusiasts do, and we want those details. And that's kind of what I have fun with, is finding ways to integrate these cool little tidbits, these little nuggets of detail of a ride, and put that into the models. So I love the fact that we can get that detail, and I love the fact that I can just go, go through Google Images of these trains and just design a proposal, and then go to a park and say, we have this cool concept, what do you think? And they're just like, wow, we didn't even ask you to do this. This is amazing. Where do I sign? So I love doing that, and finding my own way to celebrate the roller coaster aura. So.
All right. Where can people find more information about you and videos and all that?
Yeah, so if you want to follow my work, the best place is Instagram right now. So it would be Print My Ride, all with underscores, on Instagram. That's the best place. I do have a YouTube channel that I've been trying to build up, and that's also Print My Ride. So you can just search that in YouTube and find me there. And then if you want to know like where you can actually see my physical work, at Cedar Point, we have the Steel Vengeance model, which is now in the arcade. And then also at most Cedar Fair parks, soon to be Six Flags and Busch and SeaWorld, are the coaster cutouts. And you can purchase those and build wooden models of your favorite rides.
All right. Thank you very much for sitting down with us. Let's get back to the teams that are competing.
Thank you.
Hello, Charlie. This is Karen Kearns. How are you?
I am doing good, Karen.
It's been a really great day. I mean, you've done a lot of planning for this day. I am so excited to see it finally arrive.
We are very excited to see it arrive as well. So thank you for coming in as our entrepreneur in residence here at Iowa State and building this incredible Ignite Innovation showcase throughout the week. We're really happy to be here.
Yes. So I joined the Student Innovation Center probably about a year ago. And when you and I had our conversation, I remember you sitting in the lobby of the design building, and the idea of doing this big of an event was not yet part of your consciousness. And so has this lived up to your expectations?
It has certainly changed a lot and been a dynamic process coming to what this event turned into. We started out with, imagining a live in-person event and something that we hope to do in the future, and then adapting that to, having COVID regulations and making sure that we are safe in the studio. So building a large enough event here in the studio that we can all remain 10 feet away from each other and remove our masks to stay safe. And then coordinating with all of our teams around the country, with our 10 different teams, to get them, joining us virtually and to generate, as much as we can of that in-person feeling, without actually being able to be in the same room as a 3D ride model, which has been an interesting challenge. And so we've been working tirelessly and working with you to find new solutions to that, and it's been an absolute adventure, and today has gone really great so far, and we've been able to see all of these ride models and all of these teams and show off the incredible work that they've done over the year. And yeah, it's been a great day.
How this competition has really differentiated itself as far as theme park competitions go?
Yeah, so a lot of competitions in the theme park industry cover a lot of design and creative work that engineers are doing. This industry is very unique in that engineers are working very closely with artists and designers to design things that are not only functional, but look like the characters and the worlds that you know and love. And so this competition has taken, a bit of a different take than a lot of those, in that we are focusing a lot more on what ride engineers are doing behind the scenes and the technical work that those ride engineers are doing. So we've introduced a risk assessment process, which is often not taught until the final years of a college engineering program, and so we're introducing that to all of the students in this program within the context of how we do risk assessments in ride engineering. And then we've also introduced the ASTM F24 standards compliance. So these are the real safety standards that ride engineers are using, and we've allowed our teams to, design their rides and generate a document that verifies their compliance with an engineering standard. So we're having some fun. We have theming and storytelling and presentation skills and all of these extra skills that surround it. But then we've challenged our teams to really perform at the level of a professional ride engineering team. And so we've given them an incredibly high bar to reach, and our teams have done an amazing job this year, and we're hoping that in future years teams will continue to get better, and they might start surpassing the professionals who are in the industry right now, just in time for those people to graduate and become the professionals in the industry.
Yeah, one of the things we talk about at Iowa State, Charlie, is accelerating and differentiating our students' experience. And you have really done that with this event. I mean, really that spirit of Innovate at Iowa State and getting people professional ready and even advancing them in the industry. This competition has embraced that spirit and has, as you said, not only raised the bar, but really invited students to be taken seriously, to really act as if they were operating in a professional arena. And I've already, from what I've seen, they really are addressing a lot of the challenges you're laying out very seriously. It's been a delight to watch their enthusiasm, and more than that, clear to me as they are teaming and as their teams talk about what they're doing. It reminds me a lot of an Olympic event. I mean, there's a lot of camaraderie and enthusiasm and just hype. So the spirit has really been quite amazing. Do you want to talk about highlights of what you've seen today? What were the real high points?
Well, something, this is the first year of the competition, so a lot of things we left it up to the teams, and we left it sort of up to see what competition aspects would present themselves, and so what we were sort of hoping for is that we would have some models that would be experiencing downtime and experiencing those unexpected modes of failure that allow students to learn new things about their technical work and being able to test it. So this 8-hour period that we've created is big enough that it's provided a lot of time for unexpected problems to happen, and all of our teams have experienced things that they didn't expect, and new problem solving situations that they've been able to learn about their process and learn, when they were in those early stages of design, what really benefited to this final testing stage, and where they might have missed things that are causing problems now. So we're really happy that all the teams have been able to embrace the problems as they come, and work at the problems, and find some really unique situations and learn things that they didn't know at the beginning of today.
That's fabulous. And you certainly have a lot of professionals speaking in as well and participating. As you said, judges behind the scene. Can you share a little bit about some of the professionals that are participating today, some of the people that are in the industry and looking in, and what their thoughts might be?
Yeah, one of the greatest parts about this competition is we've been able to involve the industry and professionals in the ride engineering industry in, not only a few of our sponsors coaching our teams during the season, but then now during these final stages, we've had 23 judges from around the world in all kinds of different positions within the industry who have provided feedback and judging to the incredible systems engineering reports that all of our teams submitted. And then throughout the day today, they've been behind the scenes, meeting with teams, interviewing them on different concepts, and giving them feedback on their process. We've been able to work with the judges to have them, have a professional standard on the teams. And so we've been able to provide teams with feedback on any part of their process that would be different in the real world and would be more difficult. So we're giving them the tools. Our industry professionals have volunteered and helped us give these students the tools that they need to continue to grow, to continue to improve, and become the best professionals that they can be.
Charlie, share with us, how many teams total do you have competing today?
We have 10 teams competing today. We have 4 in our contactless league, and we have 6 in our model league. They're from all over the U.S., from the East Coast to the West Coast, so we're in all kinds of different time zones. So some of our teams Some of our California teams started this morning as early as 6 a.m. So it's been very unique to be able to have all of these teams together for this event, and being in the virtual space has made that a little bit easier. But we have over 80 students involved in all of these teams.
Charlie, I know you spent so much time. You put together the standards documentation. You put together, I think I saw the documents like this big. And I mean, you really put quite a bit of effort into doing this and really creating the infrastructure for doing it exceptionally well. I do think you've set the industry standard for this type of competition. How do you imagine following up? Are you planning on scaling this for next year? Or what's next on the adventure horizon for you?
This year, there were a lot of open questions about the competition, 6 months ago when we had teams signing up. And so we reached out to, clubs and other students involved in this industry that we knew would be interested in this competition and willing to sort of work with us in this first year to help us sort of figure out what this competition was going to be. So going into next year, we're opening it up to as many engineering students as we can handle, and so that's not only clubs that are out there that do theme parks and ride engineerings, but any engineering students and clubs that are at that college level can be involved in next year's competition, and we're going to try to grow it as an extended live event in the future, and it might jump around, and we have plans, going into 5 years from now of how we're going to continue to scale and grow, and we're very excited.
Yeah, so this has taken up, it's definitely a mission and vocation for you, Charlie. We've seen that very much. Your passion, really, it's uncharacteristic to see someone, a student of your age and a full-time student, really taking on something so monumental. I mean, I'm sure you've put in well over 800 hours into this competition in the last year. Just listening to how it grows and how you set it up and all the logistics of the remote environment. I mean, that alone created some really considerable challenges. As you look back on the biggest successes for you personally, really, from your sense of accomplishment and achievement, what are you most proud of? I know you're modest.
Yeah, I am. The part that gives me the greatest enjoyment is hearing from our competitors, our students, that they have learned a lot and that they have genuinely been challenged, and they've had successes and failures along the way, and that this has been a big part of their education and their journey towards becoming professionals. And then also, a big thing that was up in the air is I have a couple years of experience in this industry, but most of my experience, at Iowa State, and with our culture of innovation and student competition and student activity here, we have hundreds of clubs, and many of the engineering clubs compete in big competitions like this. And so I've been in that world, and I wanted there to be a similar competition in this industry so that I could compete in it. And then eventually that turned into, well, what if I made one myself? And so to just sort of start working on my own, and to find out that it was well designed, it is being well received, that not only the students are learning from it and it's making an impact on them, but our industry judges have been giving us feedback that this does sort of stand out from other similar competitions, and that it is going to make an impact on the entire attractions industry. going forward. That's what I'm most excited about. But for me, it's knowing that it's not just this year. We're not going to stop now. It's going to continue to grow. And so as much impact as we had this year, we'll just keep doing more and more to grow as much impact as we can.
So Charlie, tell me this, what after this competition, all these teams that are designing rides, what happens to them next? What will some of them get contracts with industries? Will some of them translate to sort of scaling for industry? What's the next step for some of these competitors?
With all of the industry partners that we've had and judges involved in this competition, they've been able to see the incredible work that these students have done firsthand, and it's been 6 months, so it's almost the equivalent of these students doing a full internship and then being able to present that outcome to professionals in the industry. And so we're hoping that experience allows them to stand out, that they are able to find more opportunities in the industry, and that buzz spreads within the attractions industry, that if you're looking for engineers for your next project, these are some of the best and most prepared students who can be your next best engineers.
Yeah, and what I love about that, Charlie, is it's not just for you, it's not just for Iowa State. You really extended kind of our land grant commitment, which is to reach out to the community, learn, make a difference, make an impact, and enhance their capacity for economic development and growth and professionalism. So we're just really proud. I'm so glad that you're one of ours, Charlie, and I really look forward to seeing what you're going to accomplish next.
Thank you very much, and we're incredibly grateful to have had your guidance and this whole program around us to support us through this process, to provide us with access to this space, and to all of the technology that we've been able to use for this event. We could not have done anything nearly to this level without the constant support from Iowa State and from our innovation program here at the Student Innovation Center. So thank you very much, Karen.
Yeah, you're one of our stars, Charlie, and I am transformed by coming into contact with you just to see what students can and will accomplish with some support and some, brainstorming, innovation mindset. You really are one of our stars. Thank you so much for the work you've done, and I'm sure that your competitors thank you as well. Good luck to you.
Thank you very much.
Bye, Charlie.
Hello everyone, we are back with another downtime highlight, and joining us is the TEA at Notre Dame group. Can you hear me?
Hello.
Hello.
Yeah.
Good to have you here. All right. Tell us about the downtime that you've experienced today.
Yeah, so unfortunately, we've experienced a bit of downtime today, primarily due to one cause. Within our attraction, we have a motor operating, and to spin the main wheel, we use a chain connecting to that motor. And unfortunately, sometimes that chain gets a little wonky and it gets a little loose, along with occasionally the motor just stalls out. So our primary source of downtime has just been a result of kind of this motor just kind of stalling. So it just requires a simple fix of just kind of giving it a gentle push, and then we get everything back on the way. We've also just had some preventative maintenance as downtime, where we've just stopped the ride for a bit just to kind of look over everything, make sure that all our screws are still tight, nothing's falling out, and just kind of, if we notice a problem within like operating the attraction, just looking it over, we'll also run this preventative maintenance just to kind of prevent it from actually failing. So yeah, we've been really fortunate that we haven't had any like catastrophic failures at all. And all of our downtime has just been relatively minimal with really no like injuries to the riders at all. Yeah.
All right. Yeah, we've been able to see on the stream your Ferris wheel ride design spinning fairly quickly.
Yeah.
What is it like to be in person with that ride? What is it? How is that speed? I don't know. What is your reaction to the speed and having that thing that you've been working on designing for so long functioning?
Yeah, I mean, it's one of the best feelings in the world, just knowing that you worked for the past 6 months, putting a ton of hours just to see this physically created in front of you. And it's something that's really cool that we created too. I think our attraction is really unique, and with the Ferris wheel and the drop aspect. So it's really cool to be able to see this concept that we visualized back in November, and see it really come to fruition. And then it's just, yeah, awesome to see it run, awesome to hear it run. It's a lot louder than I thought it would be, but yeah, it's a lot of fun just to kind of sit there, watch it run, and yeah.
So tell us more about the drop tower aspect of this. So you got sort of two ride concepts going on at the same time. What's working, what isn't? How is that sort of interaction between those two?
Yeah, so we have the Ferris wheel, which is the most noticeable aspect of our ride on the stream. And it's just, spinning the riders around in their little capsules. And then the drop tower aspect of it takes one of the capsules and drops the guests. So we have a cable and a motor, and once the guest gets into the capsule gets into the drop tower, it drops down. And then in between that, there'll be a transition from the wheel to the drop tower, and then from the drop tower to the wheel. Unfortunately, we weren't able to have that completely settled for today, and it's not operating. And as a result, we aren't able to actually have guests in the drop tower. But the drop tower is still completely functioning, and it's going up and down as it should be. But like I said, unfortunately, we can't get the guests in there due to the lack of a successful transition.
That's really interesting. We're looking at the Ferris wheel side of it, so we can't really see the drop tower going up and down.
Yeah, the drop tower is a bit hard to see just because the Ferris wheel takes up so much space, but the capsule's moving up and down. There's just nothing in there.
All right, so every hour throughout the competition, you've been replacing your riders. What is that process like of getting access to where your riders are and putting new riders in?
Yeah, it's something that we didn't really foresee coming. It's a little bit challenging. There's a little bit of small spaces that we have to fit our hands into. So within each capsule, there's the actual rider vehicle in each capsule, and it's difficult to kind of be able to reach back there and replace the riders. Especially we have two rows of seating so that we could fit 8 riders in the capsule. That back row is a little bit difficult to reach, but we're able to successfully do it and kind of replace all the riders every hour.
Fantastic. So going from your planning stages of coming up with your failure mode analysis of what do you expect to fail versus how it's gone so far. What has been different there? What's different, doing it on paper versus actually having the model there?
Yeah, there's so much that's different. And I'm sure you know. Our biggest point of failure that we identified in the ride, for like when we were writing up the report, was something that would happen in transition. We knew that one of our parts would fail after about 100 different cycles. So we knew that we would have to replace it and have scheduled downtime in there. But because that's not operating, that's obviously not something that we've had to deal with. But we've had just unforeseen downtime that we just never would have thought of in the report, such as the motor stalling. And then other things that we've had with the chain being a little bit too big. And that's just stuff that we didn't anticipate and unfortunately just can't really correct just due to the lack of resources at this point. But yeah, it's just, there's so much that goes into it physically that you just can't imagine. And you're always trying to imagine every machine that you have working perfectly, but that's definitely not the case. And because of that, we've just had some unforeseen downtime.
Well, it's great to see your model still operating and spinning around, and good luck with the last 45 minutes of your operation window.
Thank you. It's been a pleasure to be a part of the competition. You guys set up a great thing here.
All right. Thank you very much. And
thank you.
And in about 3 minutes here at 4:15, look forward to a tech talk from Linda Freeman on ASTM F24 standards and how students can get involved in the industry.
Hi, I'm Linda Freeman. I work with Rockwell Automation. We are an industrial automation company that sells technology that is used in the amusement and live entertainment industries to make things stop and start and go and keep them safe. My background's electrical engineering. I've been in the amusement industry for over 20 years. I sit on the executive committee of ASTM F24, which is what I'm going to chat with you about today. I also sit on the board of directors for Ames International. on the IAAPA Global Security Committee, looking at security concerns across attractions around the world. And I volunteer with the Student Initiative at ASTM. So I'm going to share with you today some slides that we normally show at the ASTM meetings to help students get familiar with ASTM and how to conduct themselves at meetings. And then I'm also going to talk a little bit about another set of standards for the live entertainment industry. I get a lot of questions sometimes about like Cirque du Soleil, performer flying type stuff. So we're going to talk about that today as well. So let's get started here. All right, so we're going to go over ASTM and the F24 committee, kind of what ASTM is as an organization. If you attend a meeting, what to expect during those meetings, and then how you can engage in those meetings and how you can be impactful in those meetings. We'll talk about other engagement opportunities for students in the amusement industry. And then at the end, we'll talk about those live entertainment safety standards. So first of all, what is ASTM International? That is the parent company. And then F24 is a committee underneath that parent company. So there are over 12,000 standards that are operated globally, and there's over 30,000 volunteer members with over 140 participating committees. So F24 is just one committee. There's all sorts of things that ASTM International makes standards for. It can be anything from the shoes that you wear, to the clothes that you wear, to medical equipment. There's been standards written in 2020 and 2021 around PPE for COVID. All kinds of industries use ASTM International standards, and they've actually been around since the 1800s, so over 120 years of operations. And the purpose of standards is businesses, whatever industry you're in, you need to be safe. And what's the best way to be safe is to learn from the best practices of people who have worked in the industry for years. So ASTM is a group of volunteers that get together and they share their best practices, and then they write these standards down for people to be able to use. Now, there's some learning modules that you can go online at astm.org, and when you're a student member, you can watch those learning modules. So you can talk about, you can learn about standards developments around the world, what the development process is, some of the standards examples, and then how they address intellectual property. So think about it. My company, I work for Rockwell Automation, and they pay for me to attend these ASTM meetings, and the ideas that I share in those meetings then become the property of ASTM International. So I have to be very careful that I don't share any intellectual property that is owned by my company. Now, you as a student, you're probably not going to run into that, but when you become a professional working for a company, it's something that we have to take into consideration when we come to the meetings. So here's a couple of websites for you. Students get free memberships, so join. It's a great way to get some real professional life experience as a student. I wish I would have known about this when I was a student. I didn't learn about this until 10 years into my career. So go to the website and become a student member. And then there's lots of other benefits of being a student member. They have program grant award applications you can apply for. There's different student awards. There's different scholarships. There's outreach events to Washington, D.C. when we start doing in-person things again. So it's a great way to meet professionals, get experience, and then get a leg up on your career. And also kind of figuring out maybe some areas that you want to work in, because this is going to, again, give you real life experiences. Now, some colleges and universities, they already have a membership to ASTM standards. And so maybe you can download all the standards and you can become familiar with standards in different industries. But for F24, we'd love for you to join so that we can track you as a student member of part of our committee. So when you become a student member, make sure you list F as in Frank, F24 as the committee that you want to participate in. So what is the scope of our committee? So the scope says that we shall develop standards and test methods and performance and practices and guides for amusement rides and devices. And the work of our committee, we will coordinate with other ASTM committees and other societies and organizations having mutual interest. Now, what does that second sentence mean? ASTM International is not the only standards development organization. They're called SDOs, Standard Development Organizations. It's not the only one in the world. There's actually probably hundreds of them. There's ISO, there's EN, there's IEEE, there's ANSI. And in the amusement industry, we actually have 3 global standards. The first one was ASTM. It started in the 1970s. The second one that came about was in Europe, and that one is EN 13814. And that one is only able to be used within European countries. So then there were some other international countries, Russia in particular, that said, hey, we want a global standard. We don't want to use ASTM. We like the EN. So then that's when ISO came about, ISO 17842. So those of us that volunteer at ASTM, there are some of us that also go volunteer at EN and volunteer at ISO, so that when they put a standard in place, that we're harmonized, we're saying the same thing. How do you do G-force calculations? Where do you put the device on the human to detect the G-force? We want to all be doing that the same way. Because think about it. Think if you worked for a company that built roller coasters and you had to develop and build a roller coaster for the US to ASTM standards, but then you had to go over to Asia or maybe Europe and do it to a different standard. That would be difficult. So in the scope of our committee, we say, we know we're not the only one, and we're going to help harmonize across the other organizations. And there's a lot of work that goes into that, because now you're trying to influence people in other companies, but we all have the same goal. Safety is the goal, and when it comes to safety, there's no competition. We call it co-opetition. We all are cooperating together, even though we might work for competing companies. All right, so let's talk about the structure of F24. So you have the higher committee, that's F24, and then there's subcommittees that's under the F24 committee. And we're broken up into these different committees. We're actually in the process right now of shifting some of these around, but this is how they look as of 2020. And in 2021, you might see some of these committee names change, because as our industry changes, as the type of attractions we cover change, we want to update those subcommittees to reflect the current industry. So we break up the standards usually by design, maintenance, and operations. And then we have some special attractions as well. So if we look at the list here, you'll see F2424, that's the design and maintain standards. F2440 is the operations. But then when we want to talk about parasailing, well, that's the F24.25 committee. So when you come to a meeting, you want to look for which subcommittee do you want to participate in, and then you go to those meetings, and then in those subcommittees, they might own an entire standard or they might own a part of a certain standard. So the standards do not directly correlate to each one of these committee numbers, but they're pretty close. And then there's one committee, F2490, that's the one I participate on, that's the executive committee. So we have our chairman, we have our vice chairman, we have our secretary, our membership secretary, we have all of the subcommittee leads, they sit on the executive committee, and then there's a couple of what's called interested parties, representing parties. We have some manufacturers and we have some owners. So I represent a manufacturer because we're a technology company that provides technology. So we're a supplier manufacturer. So the executive committee is the leadership that looks at all that we do in F24 and makes sure that we're heading down the right path of what the committee needs and what the industry needs. So all subcommittee meetings are open for you to attend any of them except the executive committee. Now, when you get into that subcommittee, how are things further broken down? So they break them down in what's called task groups. So we might be working on just a couple paragraphs in a standard. And so when you work on just that, we like to break it up in smaller sections because then it makes it easier for balloting. So those small sections are called task groups. So here's some examples over the last few years. They were working on loads and strengths. I lead the committee that's working on cybersecurity for safety rated control systems. So we're going to work on some language that's in the standard about design, but then we're also going to go work on some language about maintenance and about operations, but we're starting with design. We've had major modification, large rider phenomenon, the trains, and they've been doing some updated stuff with trains. So each one of these little task groups, they have different things that they work on. Then each task group is broken down into what's called a work item. And that work item is the actual little bit of language that you're changing. So a task group might be working on a section of a standard, and then they'll break that section up into smaller work groups. And then those work groups eventually turn into ballots. And then if you're a voting member, that's what you would see come through as a ballot. And when we vote on the ballot, that's what becomes new language. And that's what makes ASTM so unique compared to other standards development organizations. We are able to ballot language anytime, all the time. It does not take a majority vote even to put a ballot out. It does take a majority vote for a ballot to pass and for language to change, but we can ballot it anytime. So the fact that we can ballot a couple times a year and we can be balloting small little bits of language, we keep our standard current. We keep it contemporary to the times. But what this also means, there's constantly work going on. We constantly need volunteers. So as a student, you can be part of that today. So when do we normally meet? And this is actually something we're thinking about changing a little because COVID has shown us that we can have these meetings virtually. But historically, before COVID, the way we did it was we would have an October meeting and a February meeting. October would typically be West Coast, February would be East Coast. And then at the IAAPA Expos, always at the Orlando Expo, and then usually at the Asia and the Europe Expo, we'd have a smaller ASTM meeting. We call those outreach meetings where we give an update of what things are going on. But each one of those subcommittees and those task groups and those work groups, they are constantly working. Some of them have conference calls every week. Some of them only meet at the meetings. And so it just depends on the frequency of the work and what they're trying to update, how often they meet. So who is a part of F24? There are all kinds of people that become involved in F24. And we break our members up into 3 voting categories. So there's either producers, consumers, or users. So producers are people that build equipment. So like my company, we're a producer. Users would be like theme parks or a portable company or a zip line facility. They're people that are taking the standards and they're using them in their facilities. And then regular consumers might be someone that just has an interest in the industry. They might not work in the industry, but they want to be active and they want to be involved. And we actually have a lot of people that come to F24 who their career is not in the amusement industry, but they're very active in the industry and they participate in the standards development. And those people are valuable for us because it's a different set of ears. We always want that diversity of thought. We want people to be able to pick up these standards and read them and use them, and you don't have to have experience in the industry. And so it's important to have all those different types of people in a meeting, which is why we love having students in meetings as well. If you can pick up the standard and read it and understand it, then we know that anybody can. So we love having students to be involved. So each main committee and subcommittee, they have to have a balanced number of each member type. And the reason we do this is we don't want one company to come in and get a bunch of their same friends to come in and then they try to dominate that committee. We always want to have that balanced view, and it keeps our standardization process from being influenced from interested parties that are trying to influence. Now, ASTM is one standards development organization. I mentioned some of the others. One of those logos up there on the far opposite end of ASTM, CEN, that's CENELAC. They're the ones that do the EN standards. But there's lots of other trade associations that are in the amusement industry. So we've got IAAPA, the International Association of Amusement Parks and Attractions. That's usually fixed facilities, fixed theme parks, aquariums, museums. Then we have OABA, which is the Outdoor Amusement Business Association. That's our traveling fairs and shows. And so people that are involved in ASTM, they're typically involved in these other organizations as well. NARSO and AIMS are training organizations. Those are nonprofit organizations that teach best practices in the industry, and then they also teach these standards. So the reason why we mention this here, you know, who's part of this, when you come to ASTM and you start talking with people, you'll hear these other names mentioned. And it's usually because when somebody volunteers in one area, they volunteer in these other areas as well. And we'll end up, I'll be at an AIMS meeting and we'll start talking about ASTM stuff too. So there's lots of cross-pollination. Okay, so let's say you want to attend a meeting. What do you want to expect in the meeting? So there are different sections in a meeting. So let's say you're going to come into a subcommittee meeting, okay? There'll usually be an agenda, and there'll be what's called new business. And in the new business, that's where they bring up new topics for discussion, new proposed changes, any other concerns, new things they want to submit. And then old business will be topics where they've balloted, they need to review the balloting language, or there's maybe an old item they haven't acted on. But most of the meetings are usually broken up between old and new business. Some will do new first, some will do old first, but it's typically broken up into two sections. And when we're going through the balloting process, people can vote three different ways. They can vote affirmative, negative, or they can abstain, meaning they don't have an opinion. So like when I do my voting, I don't know a lot about parasailing. So when a parasail vote comes up, I'll usually abstain because I can't really comment. Like I don't know enough to say, is this good language or bad language? So any abstain vote, that's okay. The committee doesn't have to address that. But any negative comment, they have to address it. These ballots, before they can turn into new language, they have to have all affirmative statements. So a lot of times in these committee meetings, what they're working on is they sent out a ballot, they got negative votes back, and now they're having to go talk to that person to understand why did they make that negative vote. And they've either got to turn that negative vote into an affirmation, an abstention, or they have to put a vote to the big committee to say why that negative vote is not valid. But what's nice about this process is a single negative vote from any committee member will cause the item to be discussed at the committee level. And so a lot of times you'll hear people say, well, I don't want to go get involved in standards development because I work for a small company and we won't have a big voice. No matter the size of the company, every company has the same voice. When a large corporation shows up, like my company, we have over 20,000 people worldwide. We get one vote for that ballot item. When a company shows up that has 10 people, they get the same one vote. So that ensures that we're a consensus organization, that everybody's getting a voice. So that's important to know. That's another thing that's very unique and nice about ASTM. So how do you follow all of this? If you go online and you look at the ASTM standards, there's a lot of standards in there, and you might be like, oh, I don't know where to start. Well, here's where to start. The first one you want to read is F2291. So that's the name of the standard, and that is the design standard. In this competition, you've probably been referencing that design standard. The next important one to read is F770. That's the operations. How am I supposed to operate an attraction? Now, both of these standards were mainly written for fixed park attractions. Some of the other, like aerial adventure courses and parasailing and water slides, they've adapted this design standard, but this kind of covers the majority of it. Then there's the testing standard and the manufacturing standard. That's the four biggies. Start with that. If you were to read those before you participate in an ASTM F24 meeting, you might be ahead of over half of the people in the room, because maybe even everybody in the room hasn't read all four of those. They might have only read the one in the area in which they work in. And then how do you participate in meetings? I know when I first started showing up, I didn't know what to say. I didn't know what to do. I wasn't sure how to speak up. I wasn't sure how to provide value. And somebody gave me great advice. Just watch, just listen, learn, and eventually a question will come up in your head. If that question comes up in your head of something you don't understand, there's probably somebody else in the room that doesn't understand it either. So just ask your question. It's a learning environment. Those committee meetings, they're all learning together.
So if you have a question about something like, well, how did this issue even get brought up? Like, why are we focusing on this? Just raise your hand and ask the question. One of the areas where we can really use assistance is making suggestion for the language to be more clear. A lot of the people that volunteer in ASTM, they're professionals that have been working in this industry for a really long time. And we have our lingo. We have the way that we say things. But as a new person, you might not understand that language. And as a standards development organization, we should be writing language that anyone can understand. But sometimes we get caught up in our lingo and our jargon of the things we say for years. So if you're reading something and it doesn't make sense to you, please raise your hand and say something. Say, hey, as a new person with little experience in this area, I'm not sure someone would understand this sentence. Then make a suggestion for how to change that sentence. Because again, if you don't understand it, somebody new to the industry using these standards, they probably won't understand it either. And then if you feel you're qualified, volunteer to help with stuff. And we have a joke. We like to talk about voluntold. If you raise your hand and suggest something, you might get volunteered to help lead a group to help fix that. So you'll be surprised how easy it is to create volunteer opportunities for yourself. And I can honestly tell you, in my 10 plus years now volunteering in ASTM, some of the most valuable things that I've learned about my job and how to do things, I've learned through working with people on committees and volunteering to help do some of the language, because you really get in it and you really learn it. So how do you have an impact? You know, the professionals want you here because we need the next generation. So we thank you for being here. We thank you for volunteering. We're all eventually going to retire and somebody has to follow us. So we'd love to have you come hang out with us now before we leave. We need that diversity of thought. We need the diversity of experience. We need the diversity of perspective. Everybody comes from a different background, a different cultural raising. We need all that diversity so that we ensure we're creating the best language that's sustainable and usable for everybody around the world. So please help contribute to the standards. By contributing, I promise you will learn. What are some other engagement opportunities for students? IAPA has a young professionals group that you can join. They also just recently started a Slack channel. They have meetings, they have webinars, I believe there's a newsletter. Great way to meet young professionals in the industry. For their expos, they have what's called show ambassadors. So if we go back to doing expos in person, there is an interview process for that, and it is pretty competitive, but great experience. I know I've met a lot of great students that were show ambassadors at previous expos. With AIMS, what we started doing, I believe last year in 2020, and then we did a lot of it here in 2021 when we had a virtual conference, is we had student volunteers, just like we did for ASTM. When we're doing these virtual meetings, we have all these meeting rooms and we need assistants to help take notes, answer questions, help the moderator, or actually kind of be more like the moderator to help the speaker with questions. And we had students do all of that at ASTM F24, and we were doing that at AIMS. And so at the end of this presentation, I'm going to have 2 contact names that you can reach out to. This is being recorded as of April 2021, and these are the contact people as of that date. Another trade organization is called TEA, and that's the Themed Entertainment Association. So the Themed Entertainment Association has usually shifted more towards like live entertainment and show events, Broadway, theater type things, and where IAPA is more fixed facility type membership. So but there is some overlap between the 2 associations, so I would encourage you to check both of them out. And then TEA also has like a young professionals group. It's called their Next Gen group. And then they also have events where that Next Gen group gets together. And so TEA, they have like, it's called Gib Gab and SATE, and they have local mixers. So TEA is another great organization for you to join to meet people in industry and to learn more about the industry. So I've mentioned live entertainment. And so I'm just going to touch briefly on some other standards that are great for you to read and learn about. So all the live entertainment standards, they're from a different standards development organization called ANSI. And that industry, they really were trying to get safety to be accepted in the industry. So one of their trade associations, which is called ETSA, the Entertainment Services and Technical Association, they said, you know what, we're going to pay for the license for everybody to get these standards for free. And they created the TSP program. It's a technical program for people to learn more about safety. And if you just go Google, put in ETSA, ANSI, TSP, you'll go immediately to their website, and it lists all the standards. And there's tons of standards up there. Standards on how to do performer flying, how to do control systems for performer flying, about ropes, structures, lighting, audio, stages, rigging, effects. So that's another great place for you to go read some standards and get some real life experience. And I also challenge you, when you work on competitions and design projects, or even when you get out into the field, talk about these standards and reference them. They're pretty new. So there's actually some people working in industry today that don't even know about them. So please help spread the word about them. So here's the two people to contact. If you're a student and you want to get involved at ASTM F24, send an email to Kylie. If you want to get involved with AIMS International and learn about those student opportunities, as we're starting to create new student opportunities, reach out to Sam, and she can help you with the ASTM International. Again, my name is Linda Freeman. Look for me on LinkedIn. As you start to learn about automation technologies, check out rockwellautomation.com. Learn out about PLCs and sensors and push buttons and variable frequency drives, because without the controls, none of it moves. Thank you for listening.
That's the end of the ride portion of the competition. A Q&A between students and judges will start in an hour. Awards will be at 7 p.m. Central Time. For now, we will be rerunning promotional videos while judges deliberate. Thank you very much.